Hello students, welcome to my class. Today I will explain the properties of hydrochloric acid. And in my previous videos I have already explained the laboratory preparation and properties of hydrogen chloride gas. So students, if you have understood HCl gas, please like, share and subscribe my channel, and most important, for any doubts, please put it in the comment section and I am surely going to clear them. Okay students, so let's begin our class today, that is hydrochloric acid. This hydrochloric acid is the aqueous solution of HCl gas. In the previous video, I had shown you the demonstration of solubility of HCl gas, and I had also discussed why it does not answer the litmus or any indicator. So we'll begin with this, the difference between the properties. So hydrochloric acid, it is the aqueous solution of HCl gas. This is the covalent compound, the HCl gas, which is the covalent compound. It ionizes in water due to its polar nature, and the equation is HCl with water gives you hydronium ion H3O plus and chloride ion. About polar nature, since it is H plus and Cl minus, so it will join with, there's a bond, dative bond, about which we will discuss in the chemical bonding chapter, and will give you hydronium ion and chloride ion. The next topic is the laboratory method of preparing of HCl acid. Till now we were doing HCl gas. Now to prepare HCl acid in the laboratory will be by funnel arrangement. I have already drawn the diagram, and by this funnel arrangement we get 36% of HCl by mass. Now I will just tell you what this experiment is. I have already drawn the diagram here, which shows the beaker with water and one inverted funnel. Here the inverted funnel is actually connected to the hydrogen gas supply, and it is placed in such a way that it just touches the water level, that is the water kept in the beaker. Since HCl gas, which is present here, it condenses down as it is heavier, it is highly soluble, the water rises in the funnel. So a back suction occurs and the water rises into it, thereby creating one air gap between the funnel and the water level, the rim of the funnel you can say, and the surface of the water. And due to the pressure difference, the water which has risen will fall down. The moment water goes in to the funnel, it will immediately mix with HCl gas, and when it comes down, it will fall down, bringing HCl compound with it. So HCl gas with water will give you hydrochloric acid. So falling down every time it comes with HCl compound, and this process continues till the trough is now saturated with HCl gas, forming or resulting in HCl acid, We have just said it is a funnel arrangement to give 36% of HCl by mass. Now, this solution which you get here is then concentrated. That means then the solution is concentrated on distillation till 22.2% HCl and 77.8% water at 110 degree Celsius. And this solution which you get on distillation is known as azeotrope. That is a constant boiling mixture. That means no further increase in concentration is possible on boiling. You are concentrating, the solution which you are getting is 36% of HCl due to the funnel arrangement is concentrated further on distillation only up to this. And this particular solution is a constant boiling mixture which is known as the azeotrope. This will not be concentrated further. That means any increase in concentration is not possible on boiling. And here the back suction which I was talking about and the funnel arrangement, the reason behind it is that the back suction of water is minimized, because if a lot of water goes in, there will be explosion in the jar where HCl is actually being collected by the laboratory method. So this is minimized. As well, a larger surface is provided for the absorption of HCl gas. So a tube is not taken, a funnel is taken. Please don't hesitate to ask your doubts, if any. I will clear them all. Please like, share and subscribe my channel, and as I'm going to upload many more videos that will help you, please hit the bell icon as well. So coming to now the physical properties of hydrochloric acid. Now we are straight away going to hydrochloric acid. No more hydrogen chloride gas. And I'm going to write them for you as well. And these notes, don't worry, you are going to get them all in the description box, which will help you to prepare for your exam. So the properties are, it is first one, as we had already discussed for hydrogen chloride, it is colorless. It is a pungent, choking smell, or it has a pungent choking odor. It is sour in taste. As you all know, hydrochloric acid, acidic, the name itself is suggesting, so sour in taste. It is readily soluble in water. We have done this many a times in the videos. It is corrosive in nature. And as you should remember, causing blisters on skin. That means if it falls on the skin, it will cause blisters, putting amber color, about which we will discuss more later. Now only the properties. And volatile acid. We have just now discussed, it's a volatile acid, 110 degree. So a constant boiling mixture. About is its concentration, about the laboratory method of preparing, about its nature, covalent compound, how it can convert into hydrochloric acid, the equation, and so on. Now, we will now go to the chemical properties of hydrochloric acid, and we will do the properties one by one because there are a number of properties, actually chemical properties of hydrochloric acid, which is discussed in your book and it is there in your syllabus, and there are a number of questions also that can be asked on this part. So you should be very clear about the mechanism, which will always help you to write the equation. I will show you the mechanism. I will write the equation for you. I will also clear the types of questions that can be asked from this part. So to straight away start with the chemical properties of hydrochloric acid, the first one is it is strongly acidic. Strongly acidic in nature. So when we say acidic in nature, it will definitely answer to the indicators, and the three indicators that we always used are, first one is say moist litmus. We use methyl orange we use phenolphthalein. The color changes. Strongly acidic, moist blue litmus will turn red. You have done this last year, you have done this year before, you have done it in standard 7 also starting. We will again do the detail in the acid basis chapter. But these are the facts which you know, therefore I have not written. The methyl orange will turn from orange to pink, and the phenolphthalein will turn colorless. It will remain colorless. It is colorless, it will remain colorless. Now, the second chemical property that we are going to deal here is action on metals, all active metals. So all the metals above hydrogen, when they react with dilute hydrochloric acid, will give you a salt and hydrogen. But which salt? It is hydrochloric, so metallic chloride and hydrogen gas. So the reaction could be, say, calcium plus HCl dilute will give you the salt, the metallic chloride. Here calcium is the metal, so calcium chloride and hydrogen gas. Balance the equation. Please check the balance of the equation, which is very important, as I'm stressing on it on every video of mine. Next metal could be zinc plus HCl dilute is giving you salt, that is metal chloride. Here it is zinc, so zinc chloride plus hydrogen gas. Now writing of the equation becomes easy for you to remember when you remember the mechanism as I've written it here and with red. Metal, dilute hydrochloric acid gives the salt and hydrogen. Here with salt, metallic chloride salt. The next type of reaction, action on oxides and hydroxides. So any metallic oxide or hydroxide, when reacts with dilute hydrochloric acid, will give you salt and water. With salt, again metallic chloride salt. So here I will be giving you some of the equations. Say it is zinc oxide plus hydrochloric acid dilute will give you zinc chloride, salt, metal chloride plus water. You can try with ferric oxide, that is Fe2O3 plus dilute hydrochloric acid, giving you ferric chloride, because you have taken ferric oxide, so FeCl3 plus water. Right. You can try with ferrous oxide and dilute HCl, giving you salt. Ferrous chloride, it was ferrous oxide, so your salt is ferrous chloride and water. You can try these three I've shown for oxides for a hydroxide, so could be sodium hydroxide plus HCl dilute will give you sodium chloride, metal chloride plus water. Calcium hydroxide plus HCl dilute will give you copper chloride plus water, because calcium I have already shown it here, so let it be copper chloride. So copper chloride plus water, so let me balance it. The next type of reaction could be action of carbonates on carbonates and bicarbonates. So this one, when metallic carbonate or metallic bicarbonate, which is also known as hydrogen carbonate, with dilute HCl gives you salt, water and carbon dioxide gas. So salt means which salt? Again same, metallic chloride, water and a gas is released. So let it be, try out with sodium carbonate plus HCl and dilute will give you the salt, which is metal chloride, sodium salt, so sodium chloride plus water plus CO2 gas. You can do with bicarbonate, that is hydrogen carbonate, say calcium hydrogen carbonate plus HCl. Please mention dilute whenever it's an equation. Clear instruction should be given. That is calcium chloride plus water plus carbon dioxide gas. So yes, balanced. How do you know that this is a carbonate salt which is reacting with dilute HCl? We have to now talk about the confirmatory test of CO2, that a colorless, odorless gas which turns the lime water milky is released, which shows that the metal is a carbonate or a bicarbonate. So this kind of question can also be asked in this section. And now the next type will be maybe a sulfite or a bisulfite. So the action on metal sulfite or a bisulfite, that is a metallic sulfite or a hydrogen sulfide, that is bisulfite, when reacts with dilute HCl gives you the salt, that is metallic chloride, water and sulfur dioxide gas. In the previous one we had reacted the dilute HCl with metallic carbonate and a bicarbonate. This is sulfite and a bisulfite. There the gas given was CO2, here the gas given is SO2. And to show you the reaction, maybe I will show you with potassium sulfite plus dilute HCl acid, giving you the salt, that is potassium chloride, plus water plus SO2 gas. With a bisulfite, that is a hydrogen sulfide, maybe the reaction will be with sodium bisulfite plus HCl dilute will give you the salt, the water and the SO2 gas. Now how would you identify that it is a potassium sulfite and not a potassium bicarbonate? Potassium sulfite would give you a gas which is colorless, of course, which is having a smell of burning sulfur, and it will turn the acidified potassium dichromate orange to green, or a potassium permanganate solution purple to colorless. About all these detail of the type of gas, that is to identify the anion of the salt, I will be discussing in the next video, which will be on practical chemistry. I have already told you the reactions where the cation of the salt is identified. My next video after this would be identification of the anion, which I will be doing it very soon, and there I'll tell you in detail how to identify the gases. So for now, sulfite and bisulfite will react with dilute HCl to give you metal chloride, water and sulfur dioxide. Children, please try to remember the mechanism so that writing the equation becomes easy, as well as please balance the reactions once you have written. And if you have any doubt, please feel free to put it in the comment section and I'm going to clear them all for you. And one more thing is that I am only going by your syllabus. So please check your text. I have done all the points that is there in your text. Now the next reaction is action on sulfide. The metallic sulfide with dilute HCl will give you salt and H2S gas, that is metallic chloride and H2S gas. And here the reaction is, say, with sodium sulfide plus HCl dilute is giving you the salt, sodium chloride plus H2S gas. So it has a specific odor, it has a certain chemical test, which again I'm going to discuss in my, as I told you just now, in the video where I discuss about the practical chemistry. There is one reaction where you can identify a metallic sulfide or a thiosulfate. A metallic sulfide or a thiosulfate, where the thiosulfate reacts with dilute HCl and gives you salt, water, sulfur dioxide and sulfur, which is yellow precipitate. I have taken one example here, that is sodium thiosulfate, that is Na2S2O3 plus HCl dilute to give you salt, water, sulfur dioxide gas and sulfur precipitate, which is yellow precipitate. And this is sodium thiosulfate. So you can take dilute HCl to identify sodium bisulfite and sodium thiosulfate. Sodium sulfite and sodium thiosulfate. The only difference is that these reactions will not have yellow precipitate, where with thiosulfate, with dilute HCl, you will get one yellow precipitate. The next type of reaction, chemical property that I have taken is with nitrates. We have discussed with metal, we have discussed with metallic oxide, metallic hydroxide, carbonate, bicarbonate, sulfite, bisulfite, sulfide and thiosulfate. So many types we have discussed just now. Now to discuss with nitrates. See, dilute HCl does not react with nitrates. It will not give any test except for lead nitrate, silver nitrate and mercury nitrate. And how do you get that? You will get a white precipitate when they react. Now I have put down the reactions here. So the first one, let it be lead nitrate plus dilute HCl will give you lead chloride salt, which is a precipitate, and HNO3 nitric acid, and this is white precipitate. Similarly, a very common reaction which you had done it so many times. Now you know how it is to give you silver chloride. In my previous videos also I have written down this equation many a times. This is also white precipitate. So a silver nitrate with dilute HCl will give you white precipitate of silver chloride and nitric acid. Silver nitrate is actually used as a test for hydrochloric acid and also for chloride ion. So if you have HCl here, if you have a metal chloride here, silver and chlorine will always give you white precipitate, and you identify the chloride ion as well as used for hydrochloric acid. If you have any doubt, children, please put it in the comment section. And if you are following my videos and it is making the chapter easy, please like and share and subscribe my channel. And your doubts are definitely going to be clear. Please feel free to put them in the comment section. The next type, and very important also, here actually this is a different one from the previous equations that we were writing. They were all with dilute hydrochloric acid. Now to oxidize hydrochloric acid, we need strong oxidizing agent. So conc HCl acid can be oxidized to release chlorine gas by strong oxidizing agents, giving you salt and water also. So some of the oxidizing agents that we are going to show here, there are many actually: manganese oxide, lead oxide, red lead, that is Pb3O4, bleaching powder, calcium oxychloride, potassium permanganate, potassium dichromate. So many equations, we are not writing it here. They are all there in the textbook. You can ask me the doubt if you have any. I've written down some of them just to show you how to remember the equations. We are not mugging it up. We are going by the mechanism. So when we say any strong oxidizing agent with conc HCl and heated a little will give you salt, water and chlorine gas. So let the first one be manganese oxide, MnO2, which is, it is black in color, with HCl, now conc. Remember, little heat is required and you get a salt, that is manganese chloride, because your metal is manganese here. You get water and chlorine gas, a greenish yellow gas, a colored gas. You can try with, say, red lead, that is Pb3O4 plus again conc HCl reacted with little heat will give you lead chloride, water and chlorine gas, colored gas. You can try with potassium permanganate, KMnO4 plus again HCl, conc reacted, little heat, will give you manganese chloride and potassium chloride. There are two metals here, potassium, manganese. So two salts, manganese chloride, potassium chloride, water and chlorine gas. Bleaching powder. So bleaching powder, which is calcium oxychloride, will react with dilute and will give you calcium chloride plus water and chlorine gas. So these are some of the reactions to show you oxidation of HCl acid, giving you chlorine gas every time, and every time use of a strong oxidizing agent. The next one, which you have heard the name, that is Aquaregia. It is a mixture having 3 parts of conc HCl and 1 part of conc nitric acid. And it gives nascent chlorine that reacts with noble metals like gold and platinum. So the reaction is, as the definition says, 3 HCl conc plus 1 nitric acid conc is giving you NOCl, that is nitrosyl chloride, plus water plus nascent chlorine. So it is nitrosyl chloride, and this is nascent chlorine. Here, this nascent chlorine is a strong, very strong oxidizing agent, very reactive, so much that it will react with noble metals. Noble means it does not normally react. It can react with gold and platinum, as in gold, plus it will need 3 nascent chlorines to give you AuCl3. It will even react with platinum. And it will need 4 nascent chlorine and will give you PtCl4, platinum chloride. Now coming to the last but not the least, the uses of hydrochloric acid and the tests for hydrochloric acid. As for uses, I would say please stick to your book and see the number of uses given there. Try to learn them, children. And so far as test is confirmed, there are a number of tests that we have done in the last 3 videos of this chapter of study of the compounds hydrogen chloride. And every time you have seen giving you dense white fumes or a cuddy white precipitate or a colored gas by the use of ammonia gas or silver nitrate or MnO2 or calcium oxychloride respectively. Like ammonia gas will give you dense white fume. A glass rod dipped in ammonia solution also shown to HCl gas will give you dense white fume. Silver nitrate with HCl will give you cuddy white precipitate, or you can say white precipitate. With the use of a strong oxidizing agent, we have just seen a colored gas, a greenish yellow gas. So, children, we have discussed most of the properties given in your syllabus, as in by your text. And if you watch my video, you will see that the chapter is not difficult. All you need is practice of chemical equation, understand the facts, go by the mechanism, the reasoning ones, and the questions from the exercise given in your book, which is really going to help you a lot. Whenever you have a doubt, please put it in the comment section so that I can clear them and make the things easy for you in understanding the chapter as well as answering the test. So please hit the like button, share and subscribe my channel, and also hit the bell icon and get notified about my next video.